Hi, we're at GTI Spindle Technology at the very beginning part of our process. A spindle box comes in from the customer. We immediately remove it from the box and we enter it into our computer system, which we have a software called E2, which will track all of the spindle's activity from the day it gets here all the way through from breakdown and clean, which you'll see in this video further on, into inspection, and then further on for quoting and approval process. And we'll be completing that whole loop. And at GTI, we track these for a reason, so that anytime a customer calls or even view us on the web, you can know exactly where your spindle is within the process at any given time. Okay, this is very unusual for us to be in the run-up room at the second stage of our process, but when spindles come in, a lot of our times the spindle can be pulled from the customer off of the machine where the spindle really wasn't the end problem. So one of the unique processes we do at GTI is, if we can spin a spindle by hand after unboxing, we will put it up on the test stand and do a full vibration analysis of the spindle to determine whether it's possible that the spindle was pulled for a finish problem or any other issue with the machine and it wasn't the spindle. We do catch at least 2 to 5 spindles a month for this condition, which is a very big cost savings for our customers. And you can see our analysis equipment here on the iPad. We can quickly tell whether the spindle passes simply by hitting the report button, and it will tell us by ISO grade scale whether that is a passing spindle, and we can do other diagnostics from there. The third part of the process here at GTI is the breakdown and inspection part of our process. The breakdown is here behind me. Is kind of the dirty end of the business, but we're here in the inspection department where we'll measure all the shafts, the housings, any other critical components for run out, roundness, concentricity, because we're all bearings fit and they're ground to ABEX 7 and 9 precision. All the components that the bearing adheres to and runs on need to be as accurate as the bearing. So all these shoulders, bearing journals, both on the housing ID and the shaft OD, have to be perfect for a spindle to run well, and that's where all this inspection is done, so that we can find out what surfaces that are worn need to be ground, plated back up, and reground so that they're back to OEM tolerances, and we can come up with a cost quote to you, the customer. We are in the 4th stage of our plant tour here, which is actually one of the most critical, most important parts of what we offer the customer. And this is our cause of failure and analysis step. And we do this before the quoting process for a very important reason. Many spindles that are sent to us for repair, a spare or another spindle might be being put in its place. So if we have a machine-induced failure, we're going to want the customer to know about that as early as possible, so that they don't have another costly downtime situation and also burn through another spindle. So I've aligned 3 bearings here, just some typical causes of failures that happen, and how we identify them is kind of a little bit tricky, but with the knowledge that we've had over the years and our cooperation with the precision bearing manufacturers, we're able to find all kinds of little tricks to the trade, if you will. And this bearing here, which when it came apart to the layman's eye, you know, there really wouldn't be anything really wrong with it other than we've taken the balls out of it. The raceway's look in pretty good condition, the grease is there, but when we look a little bit closer, and this spindle didn't run very long, there are multiple ball paths on this ball rather than one path. When one path is the orbit that it's supposed to stay in with the proper amount of preload. And with the multiple ball paths around this ball, I can tell that whoever assembled it the first time where it didn't run very long, it didn't have the proper amount of preload. So the number 1 bearing in front of it just self-destructed at speed. So that's a clear indicator of loss of preload. I got another bearing here that just is impacted. I don't know whether you can see that clearly in the video, but it's just impacted with metal flakes, and you can see that those flakes and that contamination I see inside here came from the outside in versus the outside out. And this can be tricky for spindle rebuilders because a bearing self-destructs, it looks contaminated just because it blew apart in and of itself. And it's very tricky to be able to see where the contamination entered. So, but in this is a clear case that the whole labyrinth in front of this bearing was all stuffed with contamination, so that we know that is what destroyed this spindle was outside contaminants. And then my third little prop here, and we see this quite often, and this is one where, as I depicted in the beginning of this section, is a lot of people might be putting a spindle in place, and this is a lubrication failure. We took this spindle apart, the retainers were all dry, there was no residual oil, and this was an oil misted spindle. Well, now our customer, if we didn't get back to him right away, might burn through one or two more of these precision spindles if we don't get them this information that is critical and get into it quickly. And that again is why we do this in the quoting, before the quoting process, as soon as we get the spindle. So that way they can make what adjustments to the machine or the lubricator so they can stop this failure mode from happening as quickly as possible. And this concludes this section. Okay, the fifth part of our process here at GTI is the approval and quoting process. And as you can see, the administration people entering all the possible documentation, customer information, and so forth, but we also have to order all those critical parts. You know, we've got bearings, seals, O-rings, things of that we keep here in stock at GTI, so that most of those critical components are on hand to quicken the turnaround process. Once we've completed the quote, we send it out to you, the customer, and we quickly, within that day, or at the latest the very next day if we don't hear back, you will receive a phone call from GTI customer service person to let you know that it's waiting, so that we can get your spindle back up and running on your machine so you can start producing parts again. Okay, we're here at GTI's assembly bench here with Bogdan, and this is obviously one of more of the critical areas. This is the assembly process of the spindle. As you can see, Bogdan has got a spindle right here that is fully assembled, and he is in the process over here of assembling another one. And Bogdan, why don't you tell us what one of the most important critical issues of assembly process would be?
So right now I'm chasing for the square surfaces, so we won't have misalignment on an assembly. I'm checking for the gaps or how much compression the bearings will have in the housings.
Oh, for preload and all that?
I'm checking the spacers to put the right preload or to change the preload if necessary. And
squareness on those are obviously really important as well.
Yeah, yes, I'm checking for the runouts everywhere.
And how many years have you been doing this, Bogdan?
Only 15.
Only 15 years?
Yeah.
Well, that's pretty good. All right, well, we thank you for your attention on this step of the process, and we'll move on from here. We are here in the test room again, where we were earlier today on the initial vibration analysis we did on the spindle. We are in the test run room, and as you can see, we have multiple drives on the wall, multiple spindle types that we can run up, from gear-driven, belt-driven, hydrostatic, high-frequency driven spindles, belt-driven. We have several stands there that you can see. We also have vertical test run stand that we're panning in on now. And we can run AC motors and DC servo type spindles, spindle drive motors, etc. So at GTI we have a philosophy: we do not repair anything that we cannot run. And we can run at a length of time, and a long length of time, sometimes days, depending on the lubrication, whether it's oil mist or grease pack. But we also, on every single spindle that goes through, gets a thermography check. It gets a full vibration analysis. And some of your more astute people may have noticed that we've skipped through the component balancing part of this tutorial, but that is done. But we also do, with our iPad vibration analyzer, has a balancing mode so that we can suspend on a very special rubber we use to actually do a very fine trim balance, which in that case we can actually get below OEM specs for running speed, which vibration's definition of being wasted energy. Anything we can do there is longer lasting bearings for you, the customer, and a better running spindle with better surface finish and a better, safer product. So From this station here, we'll go on to another final QC even after the run-in, and we'll go there now. Okay, we are in the 8th step of the process, which I believe this is one of the things we really add value at GTI Spindle. Even though we've done a final run-in and the technician has QC'd his spindle individually, we have a special QC room where a QC elected person who is not a technician combs through every bit of work that our technicians do here at GTI. And you can see I've got a spindle here. He'll check for all the cap plugs being in the right order. He'll recheck all encoders and sensors on the spindle, recheck runout, and actually videotape that runout and save it in the customer file. And we'll check again for integrity of the windings in the field. Any critical runouts on the spindle. There is a multiple checklist of almost 40 items that we run through on these spindles before you, the customer, get it. Because one little misstep that's missed by a technician can mean that a spindle that's already scheduled to be installed into a machine would have to be pulled back out. So we have all the appropriate tooling to do the runout checks. Even on grinding spindles, we have all the appropriate quills to make sure they thread in properly, and all those checks are documented in the computer behind me, and they all go into the GTI permanent file. So if this spindle ever comes back years later, we have all the documentation that went along with that spindle to begin with. So this is a little bit redundant in a lot of people's minds to actually recheck what's already been checked, but we feel that this is an added value, and it has significantly improved our relationships with our customers and our warranty rate at a very, very decimal point percentage of what's returned here from faulty workmanship. So if it rolls through these doors behind me, it is past our QC technicians' hands. Very often it can get rolled back for a minor item, but this is the security that we offer our customers. We thank you for paying attention to this tour of GTI Spindle Technology. The final step will be packaging, where we'll show you our customized boxes as they go out the door. But as far as the spindle completion is done here, and we thank you for your attention. And if you'd like to look us up on the web, you can find us at www.gtispindle.com. Thank you once again.